so that I can upload it. Yeah. Now, first of all, we have learned integral of, let's say, x squared dx is x cubed by 3 plus a constant. This is what we have learned. Here, the value of x is indefinite. That's why we call it indefinite integral. If the value of x is defined here, then we call it a definite integral. Imagine I'm going to integrate. The value of x starts from 2. Actually, I'm supposed to write from x equal to 2 to x equal to 3. I'm supposed to write like this. But we don't write this way. We only just write 2 to 3. It is automatically understood. The value of x starts from 2 and ends at 3. In that case, what you have to do is first integrate it, x cubed by 3 plus c. Then we write 2 over here and 3 here. So after integration, the limit, lower limit is put down after the bracket and upper limit is put up. So this is a method of writing it. Then what you do is replace x by 3 in the whole function. That means you are writing f of 3. Everywhere x is present, all the x is replaced by 3. Minus replace x by 2. 2 cubed by 3 plus c. But what you'll notice about the constant will always get cancelled. So there is no point in writing this constant. So whenever I'm writing the definite integral, I don't have to write the constant because constant will get cancelled when you do upper limit, replace x by upper limit minus replace x by lower limit, c gets cancelled. So we don't usually write the constant. Then we calculate this, 27 by 3 minus 8 by 3. So I can write 19 by 3. So the value of the definite integral is 19 by 3. Okay. Now, so actual way of writing is x cubed by 3 from 2 to 3. So we don't have to write the constant. Then replace x by upper limit. Then replace x by lower limit. This way we need to write. We don't have to write this integral constant. I'll give another example. Let's say I'm integrating 0 to pi by 2 sin x dx. So what should I do first? Integrate this sin x. What is the integral of sin x? Minus cos x. Then put the limit.
So वो upper limit में क्या लिखा हुआ है?
Yeah, I get you. What you said?
Sin x के पहले जो upper limit दी है ना, उसमें क्या लिखा हुआ है?
Pi by 2.
Okay, sir.
0 to pi by 2. X starts from 0 and ends at pi by 2. That's the meaning of it. So first step is to integrate it. Then wherever x is there, replace it by pi by 2. So minus cos pi by 2. Minus. So replace x by upper limit. Minus replace x by lower limit. You know cos pi by 2 is 0 and cos 0 is 1. So your answer became 1. I hope you understood. I hope all of you have understood this this calculation. So let's divide the two things. Yeah, tell me. Yeah.
Understood, sir.
Yeah. Now, two things that you need to notice in this exercises. One is we are going to revise almost all the one problem from each of the exercise. And also we are going to learn how to put the definite integral. So one by one, let's do. Let me take your textbook questions. I'm doing alternate questions. So 15 onwards, I'm doing.
Any heading or anything we have to write?
Exercise 4.1 is not there in your syllabus. Neither it is there in the CBSE syllabus. So I don't think that is going to come in the JE also. So that particular topic I'm taking it later. If required, I'll teach you in JE. It's an interesting topic. So that exercise 4.1 is deleted. Now exercise 4.2. I'm going to do all the odd numbers and even numbers.
We'll write new topic, right?
Definite integral. I gave you the heading, no? Definite integral.
Yes, sir.
You can start with me. Definite integral. Okay, first we'll write the definition. Write the definition. If integral of small f of x dx is capital F of x. So I integrated a function. I got capital F x as the answer. Then integral a to b f of x dx is, after first you will integrate it, so it became a new function. In that new function, you will write the lower limit a here and upper limit b here. Then you will replace x by upper limit minus replace x by lower limit, and that becomes your answer. This is the definition of definite integral. How to calculate the definite integral? I hope you have written.
Yes, sir.
Yeah. Now write the
Yes, sir.
exercise 4.2. Question number 1. Evaluate integral 1 to 9 x plus 1 upon root x dx. Very simple question. So denominator is a single term. What is the method to integrate when denominator is a single term?
Sir, separate.
Separate. Very good. Very good. So x upon root x plus 1 upon root x. X upon root x, what you can write it as? Root x.
Sir, root x.
Or x raised to half you can write.
Yes,
Now we
sir.
have two choices. We can separate the integral if you want, or you may directly integrate. We have two formula here. 1 by root x integral you can directly write as 2 root x. This option also you have. Or you can go like this, x raised to minus half dx. X raised to minus half dx is x raised to half added 1 divided by half. Any one method you can apply here. So here this become x power is 1 by 2. Integration means increase the power. So 1 by 2, if you increase by 1, 3 by 2 upon 3 by 2. Since I've separated the integral, I need to put the limit also separately. Here also, x raised to minus half becomes x raised to half upon half, that is 2 root x from 1 to 9. Now this number 2 by 3, 3 by 2 will become 2 by 3. Now replace x by upper limit, 9 raised to 3 by 2. Minus, replace x by lower limit, 1 raised to 3 by 2. Did you notice that what I did with the constant? I did not keep the constant all the time. I removed the constant outside 2 by 3. Then I replace x by upper limit and lower limit so that our calculation is easier. Same way this 2 I'm going to take common. Then replace x by upper limit. Then replace x by lower limit. So my answer became 2 by 3. How to calculate 9 raised to 3 by 2? 9 raised to 3 by 2 means root of 9, the whole cube.
Yes, sir.
By 2 means take the square root. 3 means cube it. So 3
Yes,
cube
sir.
it becomes. So 27. 1 raised to anything is 1 only. Square root of 9 is 3. Square root of 1 is 2. Now I am in a position to calculate it. So I can write this as 26 into 2. 26 into 2 is 52. 52 by 3 plus 4. 3 minus 1 is 2. 2 into 2 is 4. So if I take the final answer as 52 plus 12 by 3. That became 64 by 3. So you can
Yes,
leave your
sir.
answer like that. Is it clear to everybody?
Yes, sir.
Okay. Now one problem you're going to practice yourself. Question number 2 is going to be your homework. So I'm going to question number 3. Integral pi by 4 to pi by 2. Cot square dx, cot square x dx. Anybody can tell me how to integrate cot square x? Do we have direct formula? Cot square x,
sir.
all the squares, do we have direct formula? What are the squares we have? First sine square x.
So cos x square minus 1.
Yes, correct.
Yes, sir.
Cos square x, just let me make you recap. Tan square x, cot square x, sec square x, and cosec square x. These are the square ones.
The trigonometric
Only
functions.
they both have direct formula. Sec square and cosec square x have direct formula because they are the derivative of tan x and cot x. So
Yes,
integral
sir.
of sec square x dx, we have direct formula because derivative of tan x is sec square x. For sec square x also we have direct formula minus cot x. But they four don't have direct formula. So can anybody tell me, if I want to integrate sine square x, what is the technique that we apply?
1 minus cos 2x by 2.
We replace
Yes,
it
sir.
by 1 minus cos 2x by 2. Very important integral, this 4 are. Now integral of 1 is x, integral of cos 2x is sine 2x upon 2, so everything can be integrated. Integral of cos square x dx, what is the change? Same type of formula.
Plus minus.
Plus, only thing it is plus cos 2x dx.
Yes, sir.
Then integral of tan square x. We don't have
Sec
direct
square x
formula for that.
minus 1.
We will
Trigonometric
replace it
functions.
as sec square theta minus 1, that's standard formula. Tan
Yes,
square
sir.
theta is sec square theta minus 1. Now sec square x we have direct formula, 1 we have direct formula, so we can integrate. Same way cot square x, we will write it as cosec square x minus 1. Now we have direct formula for both. So integration is possible. So let's do that. So start with me. First of all, replace cot square x as cosec square x minus 1. Now separate each one and integrate. Even if you don't separate, you can do like this also. Let me show you another method. Directly integrate off. Integral of cosec square x. If I'm integrating, then I should not put the integral sign. Sorry. Directly integrate. Cosec square x is minus cot x. Integral of 1 is x. Put the limit. Now replace all the x by upper limit. So let the minus be there only. Minus cot pi by 2 minus pi by 2. Wherever x is there, we replace by upper limit. Wherever x is there, replace by lower limit. However, the function, don't change anything. If you want, you could have taken minus common, but I'm not doing that. However, the function, let the function be the same way, and then replace all x by the upper limit. Don't forget, the middle sign is minus. Then replace all x by lower limit, which will give you minus 0 minus pi by 2. Minus of minus 1 minus pi by 4. Now we'll take the positive signs first and negative signs second. So 1 is positive, pi by 2 is negative, pi by 4 is positive. So pi by 4 minus pi by 2. So that became 1 minus pi by 4. That becomes your answer. So you will be getting a negative answer. No, pi divided by 4, 3.14 divided by 4. No, it will be a positive answer. Usually, the integral answers are always positive, but not necessary. Is it okay? Everybody? This part is clear?
Yes, sir.
Squares, how to integrate, have you recollected? So when I do one
Yes,
problem, I will always check the other things connected with it. Yeah.
Yes, sir.
Anybody else? Yeah. Okay, fine. Now question number 5 I'm doing. Question number 5. This you are quite familiar with this question. Integral 3 to 5, 1 over root of 2x plus 3 minus root of 2x minus 3. Here plus 3, here minus 3 into dx. This is also a problem from the first exercise. Do anybody know how to do this problem?
Rationalize.
Rationalize.
Yeah. Okay. So first you rationalize it. 3 to 5. Root of 2x plus 3 plus root of 2x minus 3 divided by root of 2x plus 3 minus root of 2x minus 3 into root of 2x plus 3 plus root of 2x minus 3. So integral 3 to 5, numerator became 2x plus 3 plus root of 2x minus 3. Denominator became a minus b into a plus b. So 2x plus 3 will square root will go away, minus 2x minus 3. I hope all of you understood this step. We
Yes,
had
sir.
root a minus root b into root a plus root b. So this will become a minus b. So root will go away. 2x got cancelled. So 6 became your constant here. So I'm going to put this 1 by 6 common. Directly I'm going to integrate this. I'm not going to separate it, directly integrate. You can do anyhow. If you want, you can separate them and integrate, or you want to directly integrate, that is your wish. So it will become 2x plus 3. What is the power of root? Root means raised to half. Power is half. Added 1 to it. So 3 by 2. Upon 3 by 2. Are you happy with that? Should I do something more?
Yes, sir.
What does that I have to do?
So 2 you have to
This is
multiply.
multiply by 2 in the denominator.
Yes, sir.
Coefficient of x is 2. So divide by the coefficient of x. Just let me recap you. What is the integral of ax plus b raised to n?
Sir, ax plus b raised to n upon
Yeah.
n plus 1
Increase the power by 1.
upon n plus 1 into
Yes, into a. Very good, very good. Plus c. This is the formula we have applied here.
a. Yes, sir.
Same way we are going to integrate this. 2x minus 3 raised to 3 by 2 upon 3 by 2 into 2. And the limit is from 3 to 5. So this 2 and this 2 will get cancelled. This 2 and this 2 will get cancelled. Now their constant 3 and 3 will become the 1 by 18. So 1 upon 18, 2x plus 3 raised to 3 by 2 plus 2x minus 3 raised to 3 by 2. And the limit is from 3 to 5. Is it fine? Now replace x by 5. Then replace x by 3. So let me use some other color now so that you are not confused with my steps. So 1 by 18. When I replace x by 5, it became 10, 13. 13 raised to 3 by 2. When I replace here 10 minus 7, 3, 7 by 7 raised to 3 by 2. When I replace by 3 here, 6 plus 3, 9 raised to 3 by 2. Now what I have to do? I have to put a minus sign. I replace x by upper limit. Now replace x by lower limit. 9 raised to 3 by 2. Then when I replace here 6, 6 minus 3, 3 raised to 3 by 2. That became 1 by 18, 13 root 13, 7 root 7. This became 3 root of 3, root of 9 is 3, 3 cube is 27. This minus of minus will become plus 3 root 3.
So that minus won't be there with 3.
Which one? Here it is plus, correct. Yes, dear. Minus. So there's a, when I put x as 3 here, the sign in between is plus. So this is plus. When I open the bracket, this will become minus. I don't think we can combine any of them, and you have to leave the answer like that. That is your final answer. That was your question number 5. Now I go for question number 7. Most of the questions are from the first exercise because I have not taught you how to do substitution. Can I move to the next question 7?
Yes, sir.
Yeah. Question number 7. Integral 0 to pi by 4. 0 to pi by 4. Sine 4x into sine 3x. Can anybody tell me how to go about this problem?
Multiply, divide by.
Yeah. Divide by? Yes, CD method, yes, correct. So we will have to apply 2 sin A sin B formula. Whenever two trigonometric ratios are multiplying, sine with cos, cos with the sine, sine with the sine, cos with the cos, we apply this type of formula. 2 sin A sin B is cos of A minus B minus cos of A plus B. So that we don't have a product formula. U into V, we don't apply for such problem. So whenever we have a product, we can convert it into sum or product, sum or difference by using this type of formula. So we will be writing this as, first we need a 2. So divide and multiply with 2. 2 sine 4x. Always write the bigger angle first into sine 3x. Now apply the formula. So in 2 sin A sin B, cos of A minus B is first. Cos of 4x minus 3x, directly write x. Minus cos of 4x plus 3x, that is 7x. Now can you please complete it yourself? Please complete it yourself, this integral. Integrate it and put the limit. So what is the integral of cos x?
Sin x.
Sin x. Cos 7x upon 7 will come. Now wherever x is there, replace by pi by 4. Seven pi by 4 upon 7. So we replace x by upper limit. Now replace x by lower limit. Then close the bracket. So 1 by 2 into sine pi by 4 is 1 by root 2. What about sine 7 pi by 4?
Minus 1 by root 2.
That is minus 1 by root. Correct. So do you want explanation for that? Sine 0 is 0. So everything is 0.
So there will be a 1 by 7 multiplied by 1 by root 2, no?
By 7 also. Okay. That is sine 7 pi by 4 means 8 pi minus pi upon 4. That became sine 2 pi minus pi by 4. Whenever 2 pi is there, delete it. So sine of minus pi by 4, that's why minus sign has come. So what I'm going to do now is this 0, so deleted. A 1 by root 2, I'm taking common. So 1 minus 1 by 7. So this becomes 6 by 7.
So 1 plus 1 by 7. Minus
1.
of minus.
Yes. 1 plus 1. So it becomes 8 by 7. That became 4 upon 7 root 2. Usually, if you want to keep root 2 in numerator, this is possible. So 4 root 2 by 14 you can write. That is 2 root 7 root 2 by 7. That is up to you whether to multiply numerator and denominator by root 2 or not. Even if you don't do that, it's fine. I hope you understood this step. Multiply numerator with the root 2, denominator with the root 2. But your book answer is this. This is your textbook answer. Yes. Can we move to next? Are you all ready?
Yes, sir.
Yes.
Yeah. Okay. Now we move to question number 9. Integral 0 to pi by 4 sine raised to 4x. Anybody? Method, this is quite lengthy problem.
Making cos 2x and then square.
Yes, I didn't get you. Once loudly.
Making cos 2x and then square.
Yeah, that is actually sine square x the whole square. Sine square x method of integration is 1 minus cos 2x by 2. Then we will square this. Now cos square has come. Now cos square will be replaced by the technique of cos square. Once again, I'll show you here. Cos square x was, what was the method? 1 plus cos 2x. So sine raised to 4, what we do? First sine square x the whole square. There we replace this. After replacing, you get cos square. Cos square again will replace this. So cos square will be 1 plus cos 4x by 2. Now every term here is integrable. 1 is integrable, cos 2x integrable, cos raised to 4x integrable, all of them are integrable. So this is the technique to be applied. It has come in the board exam once. This problem has come once. Yeah, when you square it, it will become 1 by 4. Correct, Sridhar. When you square it, it will become 1 by 4. Yeah. So can we start? All of you? So integral 0 to pi by 4. Sine square x will be written as, sine raised to 4x will be written as sine square x the whole square. Now sine square x, you will replace it by 1 minus cos 2x by 2 the whole square. Now after this, you will expand. A minus b the whole square formula. 1 minus 2 cos 2x plus cos square 2x divided by 4. Now this cos square 2x will be replaced. Now 0 to pi by 4, 1 minus 2 cos 2x plus cos square 2x will be replaced by 1 plus cos 4x by 2. Now I'm going to take the LCM. This 2 plus 1 will give you 3 minus 4 cos 2x plus cos 4x. And the denominator will become 8. I hope I skipped a step. This 2 into 1 plus 1 here also. So that's how I got 3. This 2 multiplied with this 1 and then added this 1. So it became 3. Then this 2 with this 2 give you 4. Now I can integrate each and every term. So 1 by 8 I am taking common. And integrate each one. 3x minus 4 sine 2x by 2 plus sine 4x by 4. Now put the lower limit to 0, put the upper limit to pi by 4. Now we will replace all the x by upper limit. So 3 pi by 4. This 4 and this will get cancelled. Minus 2 sine 2 times pi by 4 is pi by 2 plus sine pi upon 4. What I have done, wherever x is there, all the x has been replaced by the upper limit. Minus, replace x by lower limit, 3 into 0, 2 into sine 0 plus sine 0 by 4. And here we don't have to worry much about them because all of them are 0. Sine 0 is 0. So here is my final calculation. 1 by 8, 3 pi by 4, minus 2 plus 0 by 4. So if I take LCM here, 3 pi minus 8 upon 64. No, upon 32. Am I right? Shagun, my calculation is correct.
Yes, sir.
So this is a very important question. One of the board examination, they asked this problem. Now we will move to question number 11. Yeah, I was waiting for this problem. All standard formula problems we are doing. Can I move to the next one? All of you ready?
Yes, sir.
Okay.
Yes.
Before I start writing the question, just let's recap. What should I do for this type of problem when there is a quadratic like this?
Make perfect square.
Make it into complete the square and convert it into which format? Either 1 upon x square plus a square, or 1 upon x square minus a square, or 1 upon a square minus x square. If there is a square root, the formula changes, that's it. Do you remember these 6 formulae? Okay, let me recap the 6 formulae. First formula, x square minus a square. Second formula, a square minus x square. Third formula, a square plus x square. They can be factorized. So the answer is log. Can anybody tell me the answer?
1 upon 2a
1 upon 2a.
log x minus a upon x plus a.
Very good, very good. X minus a upon x plus a. What is the formula for this? 1 by 2 log a plus x upon a minus x. When the constant is first, it is a plus x. And the formula for this is it log?
No, it's tan inverse.
1 by a tan inverse x by a. Then we have 3 more formulae with the square roots. X square minus a square. This is also log. log of x plus denominator. See, there is no prefix in when there is a root. There are prefix 1 by 2a, 1 by 2a, 1 by a when there is no root. When there is square root, no prefix. Then I am going to go to root of x square plus a square. This is also same formula. Log of x plus denominator. Then comes the last formula. I don't want to change this. Root of a square minus x square. Whose derivative is 1 upon root 1 minus x square?
Sine inverse.
Sine inverse. So your answer is sine inverse. So no prefix, sine inverse x by a. You know 1 upon 1 plus x square is tan inverse derivative. So a square plus x square will be in tan inverse. A square minus x square with the root will be sine inverse. Okay. Now we will go to the problem. All right. So this is a very good problem. Question number 11. Integral 0 to 4. 1 upon root of 4x minus x square dx. Here x square's coefficient is negative. If x square's coefficient is negative, you need to apply this formula. That means you need to complete the square such a way that a square is positive and x square is negative. So do anybody remember how to complete the square here? Yes, some chat. No, we cannot use the previous solution. Okay.
Divide x term by
0 to 4. What you do is, inside the square root, take a minus common. Okay. Now to make this a perfect square, I must add half the coefficient of x, square of it. Coefficient of x is 4. 4's half is 2. Then square it. So it became 4. Add one 4 inside the bracket and subtract a 4 outside the bracket. I'll use some other color. Add a 4 here and subtract a 4 here. So in fact, adding 4 is over here, subtracting 4 is over here. Is this 4 you understood? How did you get this number 4? Coefficient of x divide by 2 and square it. Coefficient of x divide by 2 and square it. Now once you do that, this will turn to 0 to 4, 1 upon root of 4 minus x minus 2 the whole square. So it became in this format. Let's look at the format. Look at this format. Constant is positive, x term with the negative sign. So whenever the coefficient of x square is negative, you must always have the coefficient of x square negative after the completing the square also. Now we can directly apply this formula. So when I apply this formula directly, what will be my answer? Sine inverse x minus 2 upon a. A square is 4. So a is 2. Now you can put the limit 0 to 4. Now replace x by upper limit. Sine inverse 4 minus 2 upon 2 minus sine inverse 0 minus 2 upon 2. So that became sine inverse 1 minus sine inverse of minus 1. Because 0 minus 2 by 2 will be minus 1. So that minus and minus will become plus. So it becomes pi by 2 plus pi by 2. So answer is pi. Pi is your final answer. Is that fine with everybody? I hope you recapped the completing the square method. So basically, by the time I finish this definite integral, one revision of all the types of questions will come across. So that is also a revision for definite integral. Today is all standard formula. Tomorrow is substitution method, probably. So like that, I will keep on completing it. Can I change the page? Can I change the page?
Yes,
Yes,
sir.
sir.
So
Now comes the most important one, integration by parts. So substitution method, I have not started it, okay? Integration by parts, integral uv dx. I gave you a shortcut to remember this formula, fis minus integral dfis. So remember that the limit should be applied after the whole integration is completed. You should not apply limit in between. Like here, your derivative is there, again integration is there. So you should not apply it directly. I'll just show you, you don't write. Imagine the question number is 13, integral 0 to pi by 2, integral 0 to pi by 2, x sin x. I want you not to write now, just observe. Just recap. I know many of you must have not last 2-3 days, not 1 week, you have not studied integration at all. You must have missed out, some of you at least. So that's why I'm explaining you from the basics. How do you define? How do you decide which is the first function and second function? By LIATE. Logarithmic, inverse trigonometric, algebraic, trigonometric, exponential. We have x, which is called algebraic. We have sin x, which is trigonometric. Algebraic is before trigonometric. So this is your first function and this is your second function. Now just substitute in this formula. First function as it is. Integrate the second function. Minus integral of derivative of first, integral of second. Now, one most important thing to remember, after the complete integration is done, you are supposed to put the limit. Don't put the limit in between, you may go wrong. If I put the limit over here, this x will have no value. Value of x is 0 to pi by 2. Suppose I put limit here, what will happen? I will be only applying limit for sin x. Same way, so those things will become wrong. You are supposed to integrate completely, then only you are supposed to put the limit, because you remember the definition. Just look at the definition of integration. Beginning that I told you, the integration should be completed. After the integration, we have to replace x by upper limit minus x by lower limit. I hope you remember this. Okay. So let's complete the integration. In the x, integral of sin x is minus cos x minus derivative of x 1, integral of sin x minus cos x. We have to integrate once more. So minus x cos x. So this job is done. Minus of minus plus, integral of cos x sin x. Now you can replace x by upper limit. Minus pi by 2 cos pi by 2 plus sin pi by 2. Now replace x by lower limit. Minus 0 cos 0 plus sin 0. So answer became minus pi by 2 cos pi by 2 is 0, sin pi by 2 is 1, and everything else is 0. So your answer became 1. Now, although I said, listen carefully now, just all of you just pay attention 1 minute. Although I said that integration should be completed, then only I should apply the limit. But there's one more possibility that you can do. You have seen that this step is completed over here. There's nothing more to add here. So some of your books may do this manner. Just look at it. They will write it this way. There's nothing wrong in this method. They will put the limit here separately and then put the limit here. It is not wrong. It is correct. Because after this integration, you have no much work on this. So you can start putting the limit in this, especially when the problem is very lengthy. So one with the terms which completed integration, you can start putting the limit. And the terms which have not yet completed the integration, you can continue. But never put the limit here. This will go wrong. This is wrong. The small integrals should not have this and this. Don't put the limit there. If you put the limit there, it will go wrong. So my suggestion at present is the way I taught you, please learn that method. What is the method I told you? Complete the whole integration, then put the limit. Later on, I will change my words. Later on, when the problem is very lengthy, then I'll say, okay, let's put the limit wherever the integration is completed. But initially, learn it in this way. Integrate, complete limit integration is completed. Complete integration is over. Then put upper limit and then put the lower limit. Is it clear? Yeah, just practice once yourself this problem. I'll give you more practice because this is also a common question in the exam. Integration by parts with a definite integral. Do you need more time? Anybody wants more time to write the solution? Okay, then I'm moving to the next. Question number 15. Question number 15. Integral 0 to infinity. X e raised to minus x dx. So again, we'll go by Fish minus integral de Fish method. LIAT, exponential is last. So this is second function and this is a first function. Just try yourself. All of you try yourself. First one as it is. Integral of second minus integral of derivative of first integral of second. Do not put any limit anywhere on this integral. Don't put any limit here. Put the limit after the integration. Derivative of x 1 e raised to minus x upon minus 1 into dx. Remember, integral of e raised to ax dx is e raised to ax upon a. That's why this minus 1 has come in denominator. So minus x e raised to minus x. This minus of minus will become plus. But when you integrate e raised to minus x, again one minus will come. Now I'll replace x by upper limit. So what I can write here as minus x upon e raised to x minus 1 upon e raised to x. When you replace x by infinity, this number is smaller. Exponential numbers are much bigger. So denominator become much larger than the numerator. So it become infinity here, denominator infinity, minus here also denominator infinity. Replace x by 0. This becomes 0. This will become 1. So this all are zeros. 0, minus 0, minus 0, plus 1. Or minus 1, sorry. So your answer is 1. Any doubt in this step, how I made this to 0? Sir, I have. Yeah. But now we are, Sridhar, we cannot use any trick at present. That I'll also teach you when we do MCQ. At present, we are learning how to apply integration by parts. So let's go ahead with this method. I'll also give you some tricks after we have completed the chapter. Okay. Any doubt? Sridhar, I didn't understand that 1 by 4. What was that 1 by 4? Oh, that is a previous question. Okay. I got it. I saw your previous chat. Okay. Yeah. Question number. I hope all of you understood integration by parts definite integral. Now I am going to start with substitution method. So you can give the heading substitution method. In definite integral. How to do substitution? What is the change in the when we do substitution method? Remember, substitution method means change of variable. So naturally, when you change the variable, the value of the variable also will change. So that is all we have to remember. When you replace something by t, the value of x cannot be applied on t. Value of t has to be applied on t. So that's all you have to understand. So let me show you one question. That is question number 1, second part. Integral 0 to 1 by root 2. Sine inverse x divided by 1 minus x square raised to 3 by 2 dx. So this I can rewrite it as 0 to 1 by root 2 sine inverse x upon 1 minus x square into root of 1 minus x square. Why did I write that way is to just make you understand whose derivative is present. Naturally, sine inverse of x derivative is present. 1 by root 1 minus x square. Only thing is this also should be converted to sine inverse. Sine. That x should be removed. So it is very clear. We need to put sine inverse x as t. This is very clear. So look at the method I'm applying. What are the things to remember? Put sine inverse x as t. Then 1 upon root 1 minus x square into dx equal to dt. What did I do? I differentiated with respect to x so that the dx can be removed. But dx akela you cannot remove. Dx with the derivative only can be removed. Now I need to remove this also. So from here I can say where x is present, replace it by sine t. Now that is not enough. Whatever the value that you see 0 and 1 by root 2, they are the values of x. But we have changed the variable to t. So corresponding value of t to be calculated. So I am going to write most important step. When x takes value 0, what will be the value of t? T's value will be sine inverse of 0, which will be 0. When x takes value 1 by root 2, what will be t? T will be sine inverse of 1 by root 2, which is pi by 4. So now my integral will change totally. Integral will be 0 will be when x is 0, t is 0. So 0 only. When x is 1 by root 2, t is pi by 4. Sine inverse x became t. 1 minus x square became 1 minus sine square t. Dx upon root 1 minus x square became dt. So my question now changed to zero to pi by 4 t will be t only. 1 minus sine square is cos square. When you go to numerator, it becomes sec square t. Now our usual integration by parts. I hope you understood this step. Any doubt anywhere in any of these steps? Why limit is changed? Did you understand? Why did we change the limit? Because variable is changed. X became t, so t's value should be put, not x value. Usually, students forget to change the limit, and hence your answer become a vague answer. So you have to be very careful. Whenever you do substitution method, not only substitute, but also change the limit. Now, trigonometry is second function, LIATE. Algebraic is before trigonometric, so algebraic is first, trigonometric is second. So first into integral of sec square x, I'm writing directly tan t minus integral of derivative of t is 1 into integral of sec square t tan t dt. I took a shortcut. You are also allowed to do this, the exam. So that became t tan t into tan t. Integral of tan t is log sec t. 0 to pi by 4. Now replace x by upper limit, pi by 4, tan pi by 4 minus log sec pi by 4 minus 0 minus log sec 0. Now sec 0 is 1. So log 1 is 0. So this whole thing is 0. So pi by 4 is 1. So your final answer will be pi by 4 into 1 minus log of root 2. So pi by 4 minus half log 2 if you feel like you can write. This will be your answer. Is it fine?
एक मिनट
Everybody?
मैं लिख लेता हूँ.
All of you understood the substitution method?
Yes, sir.
Yes, sir.
So what to remember in substitution method? We have to change the value of the x to value of t. When we change the variable, the value of the definite integral also should be changed. This should not be forgotten. I think I have time for one more problem, and then I'll stop. Question number 3.
Yes, sir.
Oh, very interesting question. Question number 3. Quite common question in the board exam. Even JE wants this question asked. 0 to pi by 4, very long back. Sine 2x divided by sine raised to 4x plus cos raised to 4x. Excellent problem. Yeah. Angles are different. We cannot do anything unless if angles are different. So make the angles same. That's the first thing to think in your mind. So sine 2x is 2 sin x cos x. So I made the angles same. Anybody know the method? Anybody know the method for this problem? There are 2 methods to do this problem. By looking at the numerator, you can decide what to substitute. Another is you can modify and substitute. Anybody? We have done this in indefinite. Anybody? 2 sin x cos x is whose derivative? 2 sin x cos x is the derivative of which term?
Cos square x.
Sine square x.
Sin square x. So one option is you can put sin square x as t. But that is little lengthy. if you divide numerator and denominator by cos raised to 4x, divide numerator and denominator by cos raised to 4x, then this problem becomes very beautiful problem. Just look at this. 0 to pi by 4, 2 sin x cos x divided by cos raised to 4x. I want you to write this problem on your wall, because you cannot remember so easily this unless you keep on reminding yourself. This is a likely question for MHCT. It's also a likely question for JE. It is a likely question for board. Now the numerator became very interesting. 2 tan x into sec square x. Check whether it's right or wrong. Sec square is 1 by cos square. One cos got cancelled, so you have cos cube x. One cos got attached to sin x to give you tan x. Remaining cos square became sec square x. And the denominator became tan raised to 4x plus 1. Now tell me whose derivative is numerator.
Sec
Can anybody?
x.
Whose derivative?
Sec x.
Of course, tan x derivative is sec square x. But little more, observe it properly. Whose derivative is the whole numerator? 2 tan x into sec x, sec square x. 2 tan x into sec square x is the derivative of
tan square x.
Tan square x. Very good, very good. So my option here is to put tan square x as t, and my problem looks much shorter. That's why I told you, you must write this problem on the wall. It's not easy to remember. So I have the derivative of tan square x here. So put tan square x as t. So that 2 tan x into derivative of tan x dx. It can be replaced by dt. Then what is the most important thing to remember? We are changing the variable to t. So the limit also should be changed. So you will ask the question, when x takes value 0, how much is t? Is also 0. When x takes value pi by 4, how much is t? It will be tan square pi by 4, which will be 1. So the limit will be 0 to 1 dt upon t square plus 1. Whose integral is just by heart for you? It is
Tan inverse.
Tan inverse. So tan inverse t from 0 to 1. What a beautiful answer. What a beautiful question. So tan inverse of 1 minus tan inverse of 0. The paper setter always will like this problem because it's so smooth to do the problem. No big calculations. All are beautiful calculation. And the substitution is too beautiful. So it's quite likely problem for some of your test. Okay, I certainly will ask you this question at least 2-3 times in my test. I hope you understood today's class.
Yes, sir.
Yes, sir, we understood, sir.
Sridhar, your method will be very lengthy method. That's what I told you in the beginning. So this method is the fastest method and the best method. And yeah, let me just close my recording.